In this video, we're going to talk about 2.6 Objective 5, where we evaluate limits using continuity principles. So if I have limit of f of x to the n here, I can take the limit of this. If this function on the inside has a limit L, it'll be L to the n, will be the limit of the entire composite function here. So let's go ahead and find the limit as I go to 0 of the inner function. That's going to be 1. 1 to the 39th is going to be 1. Now let's go ahead and see what happens when I stick 2 in here. 2 over 3 times 16 minus 2 times 4 minus 37. Let's figure that out is 2 over 32 minus 8 minus 37. It's 2 over, this is 28. It's a negative 9. So negative 2/9 squared is 4 over 81. What did I do wrong there? This is 48. Let's say 40. This is 3. 4/9. There we go. As x approaches 6 here, let's see, this is x minus 6, x plus 4. So this is going to be 6, 10. Root 60 is 2 root 15. Root t plus 5, root t minus 5, root t minus 5 will cancel. That limit will be 5 plus 5 is 10. Limit t goes to 25. This is 10 over 5 is 2. 2 to the third is 8. This is 625. No, that says 26. I think that that's going to be a 0 over 0 situation. So let me rationalize here. Make this x squared minus 100 minus 24 squared over 2x minus 52 times x squared minus 100 plus 24 squared. That is 625 minus 50 plus 1 is 575. 1 is 576. That is x squared minus 100 minus 576 over 2x. This is 2 times x minus 26. And 26 times 26. 75 plus 50 plus 1, 675 plus 1 is 676. This is x squared minus 676. This is x plus 26, x minus 26, 2 times x minus 26 times that square root. This is x plus 26 over 2 times the square root of x squared minus 100 plus 24. When I stick 26 in, 26 squared is 676, minus 100 is 576. So that's going to be 24, 2 times 24. Sorry, 2 times this, 24 plus 24, that's 48. 2 times 48, that's 96. And then this is 20, that's 52. This is 2 times 26 over 2 times 2 times 24. This is 13, 12, 13 over 24. Yeah. And then all that needs to be cubed. And I'll let you do that in your calculator. So 13 cubed is going to be 2197 over 24 cubed is going to be 13,824. All right. I used up some of my space for number 7 to work on number 6, but let's go ahead here and see if I can just stick in 5. 15 plus 3 is 18 over 10 minus 2 minus 8 is 2. This is root 9. That should be 3. There we go. Sine x plus 1 plus 5 sine x plus 1 sine x plus 5, as long as sine x is not equal to -1. And at 3 pi over 2, sine is -1, so that's a problem. There's a 0 in the denominator there. So the function we're going to get a hole in the graph here, but it's not defined there. So the limit is going to be, let's see, -1 plus 5 is 4. Sine x is continuous for all x, and some squares, constant multiples, continuous functions are continuous. We just have a problem here, like I said, that we get 0 over 0. There's going to be a hole in the graph there, but the limit's going to exist. As I get close to 5 here, 25 plus 24 is 49, and that's going to be 7. This limit here, as I go to 0, is going to be let's make a common denominator here. 5 minus sine theta over 5 times 5 plus sine theta times 1 over sine theta. This is going to be a negative sine theta over sine theta is going to be a -1. This is -1 over 5 times 5 plus sine theta. Take the limit as sine theta, as theta goes to 0, that's going to be a -1 over 25. This is 1 minus cosine squared x, 3 cosine x minus 1. So that's a -3 times cosine x minus 1 over cosine squared x minus 1. -3 cosine x minus 1, cosine x plus 1, cosine x minus 1 is going to be -3 over 1 plus 1. That's a -3/2. And 3 over, let's cosine x. I multiply this by cosine x plus 1, cosine x plus 1. Cosine squared minus 1 is a negative sine squared, so that's a -5 sine squared x over sine squared x times cosine x plus 1. It's a -5 over cosine x plus 1. And that is a -5 over 1 plus 1 is a -5/2. Special trig, oh, nope, this is squeeze theorem. So this is going to go to 0 because this is going to stay between -1 over t squared. And 1 over t squared. And this limit goes to 0, and that limit goes to 0. So this limit also has to go to 0 by the squeeze theorem. Determine the intervals for which cosecant is continuous. Well, it's continuous everywhere where sine is not 0. Sine is 0 at multiples of pi. So x is not equal to n pi, where n is an integer. Then analyze the limits of f of x as x approaches pi over 4. So that's going to be √2. And then as I approach 2 pi, sorry, -2 pi from below, so more negative than -2 pi, I'm going to be coming from this side here, and the sign value will be positive, so this is going to go towards -2 pi smaller value. Let's look at the graph here. So we have 0, pi, 2 pi, pi, negative pi, negative 2 pi, 0, pi, 2 pi. I'm only interested on this side. But over here, this is quadrant 1, and we're up here. Then we're down here, and we're down here, then we're up here, then we're down here. So as I get at negative 2 pi from the left, it's negative infinity. Okay. Now we're going to evaluate this here as I get close to pi over 6. That's a half, 17 halves. Fourth root of 17 over 2. Don't know that I need to get more exact than that. It's okay as long as sign is greater than or equal to 0. The sine function, figure that out. We can't be pi to 2 pi. We can't be negative pi to pi, and so on. You have to stay like between 0 and pi here. So this is going to be all intervals in the form of 2 pi n to 2 pi n plus pi, where n is an integer. It's going to be correct. And then as I approach 0 from the right, so that's sign value is going to be positive, we're going to be getting close to 0. As we get close to 0 from the right here, that's going to be 1 over 0 from the right. So that's going to be a positive number over 8. Number that's slightly positive, so that's going to be positive infinity. This first part here. And then as I approach 7 pi over 6, so we're down in quadrant 3, cosine will be negative there. 4 plus 4 times negative root 3 over 2 over, and then this is going to be a negative 1/2 here. So this is going to be a negative 8 minus plus 8 root 3 over 2. So this is negative 8 plus 4 root 3. And again, what's the domain here for this? Sine is not allowed to be n pi or n plus 1 pi. There we go. That's it. It's that, and it's use the identity for the sum difference identity for sine, sum difference identity for cosine here to find what happens with sine of a plus h when x goes to 0, sine of x equals 0, cosine of x goes to 1. Let's find limit of as x approaches a of sine x. So sine of, let's say, I think what they want me to do is sine of x plus h. So limit as x approaches a of sine of x plus h equals limit as x approaches a of all of this. So this is going to be sine is going to be continuous at a, so we're just going to get d. Cosine is going to be continuous at a, so we're going to get this one. I don't know why we needed to know these identities. Don't worry about all that. We'll find some difference quotients though, and do some stuff with derivative limits of trig functions later, where we'll need to know that. Determine the following limit. As I get close to 2 pi, this is going to be cosine of 2 pi is going to be 1. So this is 2 minus 5 is negative 3 over 4 pi. Say negative, yeah, negative 3. And that's it for this video. We'll come back next time and we'll talk about 2.6 Objective 6. See you for the next video.